In this video, we'll look at a few examples of volume problems. We'll need the volume section of our class formula sheet, which is this section here. Example 1 says, Linda is the manager at the Colony Apartments and needs to replace the sand in the rectangular sand volleyball court. The court is 30 feet wide by 60 feet long, and the sand has a uniform depth of 18 inches. Volleyball court sand sells for $15 per cubic yard. How many cubic yards of sand does Linda need, and how much will the sand cost? The shape described is a rectangular solid, so volume equals length times width times height. But our measurements are not all in the same units, feet, inches, so we need to convert one or more. Since the first two measurements are in feet, let's convert the depth, which will be h in the formula, into feet. So writing our formula, volume equals length times width times height. And now to convert, we need our conversions from the formula sheet. We need 12 inches equals 1 foot. So to convert from inches to feet, we're going to divide by 12. So to convert 18 inches into feet, we're going to take 18 divided by 12. Equals 1.5. feet. So doing our volume calculation in feet, our volume equals 30 times 60 times 1.5 feet. And that equals 2,700 cubic feet, or we'll write it like feet cubed. Part A asks how many cubic yards of sand Linda needs, and we just found cubic feet. So we'll need to convert. The conversion that we'll need is 27 cubic feet equals 1 cubic yard. So divide 2,700 cubic feet by 27. $2,700 divided by 27 to get 100 cubic yards, or we write yards cubed. And that's the answer to part A. For part B, how much will the sand cost? We multiply $15 per cubic, $15 by 100 cubic yards to get a cost of $1,500. Example 2 is the volume of a pyramid. That formula for the volume of a pyramid has an unusual variable, this capital B. Usually a variable in a formula represents just one measurement, but B represents the area of the base of a pyramid. The base can be different shapes, a triangle, a square, a rectangle. So we first find B by using the appropriate area formula for whatever that shape of that pyramid is. and then we find the rest of the formula. The pyramid volume formula is V equals 1/3 times capital B times H. So V equals 1/3 B times H. This particular pyramid has a rectangular base. So for our capital B, we use the formula for this shape, which is the area of a rectangle. So A, or B for this formula, equals length times width, which is 6 times 9, or 54. Substituting that value into the volume formula for B, we get volume equals 1/3 times B, which is 54, times H, which is the height of 16 inches. On the calculator, you can enter 1/3 as 1 divided by 3. Or a different way to do it would be to enter the 54 first and divide that by 3. Then times 16 equals 288 cubic inches. Or we can write inches cubed. Example 3 is to find the volume of an ice cream cone. We don't have an ice cream cone formula, so we'll need to break this into two shapes that we do have formulas for. Well, the bottom part of the figure is a cone. Volume equals 1/3 pi r squared h. The top part is a hemisphere, or half of a sphere. The sphere formula is volume equals 4/3 pi r cubed but since it's a hemisphere, we'll have to multiply that by a half. For the cone, we need the height and the radius. The height is 10 centimeters. The diameter all the way across is 7 centimeters. We need the radius, which is half of that. So 7 divided by 2, which is 3.5 centimeters. So the volume is 1/3 pi r squared, so 3.5 squared, times the height, 10, we can enter this in the calculator as 1 divided by 3, then times pi, or another way to do it is enter the pi first and enter pi divided by 3. Then times 3.5 squared, you can enter times 3.5 and you can type again times 3.5 for the squared, or you can use your exponent key, which could look like this little up arrow caret, or on this calculator it's this button here, y to the x, like an exponent. In some calculators that's reversed, it could be x to the y. So if I go, so I have the 3.5, and if I hit the exponent button squared, then that'll square the 3.5. And then multiply times 10, or here, times 10, which equals 128.2817. So that's the cone. For the hemisphere, volume equals 1/2 times 4/3 times pi r cubed, and r is the same, 3.5. So our hemisphere volume is 1/2 times 4/3 times pi, times r, or 3.5, cubed. We can enter this on the calculator as 1 divided by 2, or you could have just entered that 0.5, times 4/3, so times 4 divided by 3, times pi, then times 3.5 cubed, so 3.5, exponent key 3. And I'm not sure where that 42 that was there a moment ago came from, but the answer should be 89.797. So for our total volume, we would add those two volumes. The volume of the cone, 128.2817, plus the volume of the hemisphere, 89.797, which equals 218.0787. If the directions don't specify where to round your answer, then a good rule of thumb is to round to the nearest tenth, 1 decimal place. So here, since we want to round to this first decimal place and the next place over has a 7, which is 5 or more, that tells us to round up to 218.1. cubic centimeters, or centimeters cubed.